EnerCalc 3D has many useful tools for visualizing and reporting on analysis results. So if we look down in the lower right-hand corner and notice that this model indicates that it has been solved, we should be able to come to the Analysis Results tab and take a look at some of what's available. Now this won't be an exhaustive look at everything that the program offers for analysis results, but rest assured that if there's something in here that's of interest and we haven't covered it, it is covered in the user's manual, so feel free to look up the details there. We'll just hit on some of the more commonly used items here, starting with nodal displacements. When I click nodal displacements, the table opens up. As expected, we see a list of nodes and then displacements in the X, Y, and Z and rotations about the X, Y, and Z. And the only thing that I really want to mention here is that it's a good place to point out that most of these tables behave the same way in that they have a load combination drop down, and the results that you view in the table are specific to the selected load combination. We have a story drifts button, and in fairness, I want to mention that there was one step of setup that was required before we could produce these results. That was that I needed to select the nodes that I wanted to study for drift, and I just chose these nodes at the far left corner column. Once I select those and identify them as drift nodes, then the program is able to populate this table that's useful for studying drift effects for lateral loads. And we can come into this table and see story heights, and then we can see total displacements in the X and the Z direction. We can see story drifts or interstory drifts, and then even a drift ratio. So this does a lot of the work for us in terms of boiling down lateral displacement and relating it to story heights. When I come to support reactions, we'll see that we have reactions for a whole bunch of nodes, all of the supported nodes out there, in fact. And here what I'd like to do is temporarily close the table and then come out to the model and just select two nodes of interest and then come right back in to that same table. This way I can point out that many of these tables offer this show selected only checkbox. Notice that when I toggle that, a couple of things happen. Number one, it's obviously related to this button up here. This button does the exact same thing. And also, it filters. It filters on the selected elements out there in the model. So since I selected two nodes, I see 2 rows worth of results, and then I could drill into the load combination of interest and read specific values for those nodes. Member end forces and moments is a table that reports forces, torsions, shears, moments, etc. at the starting end and ending end of all of the members, or at least all of the members that are selected to be viewed. And then similar to that, we have another table called member segmental results. For this table, we can see that we have a breakdown of many different force direction values, and notice that they're at many small increments along the length of the member. And what I'd like to point out here is how that small increment value gets established so that you'll know how to adjust that for your use. What you can do is come to Analysis, Analysis Options, and then here, number of segments for member output. Notice that it's set to 20. That's what's driving that increment, and that's why we were seeing 0.05 unit steps along the length of the member. So if you have a need for coarser or finer results, you can change it there. Let's come back to analysis results and talk about shells. Notice that we have shell forces and moments. So in this table we can see many different types of shears and moments that act on shell members or shell elements. The important thing that I want to mention for this table is that in the current view, notice that they're all listed as being values that apply to the center of the shell. We also have an option to change that to look at forces at the nodes of a shell, and I'll show you where that is. We can come to Settings and Tools, and then come to Data Options, and here is the drop down for Show Finite Element Stresses At. So it's obviously set to center only. We can choose nodes only or both nodes and center. And then if we were to come back to Analysis Results and look at shell forces and moments, we can now see all four corners plus a center value. Put some real numbers there. Next thing we'll look at is shear and moment diagrams. If I come to the shear and moment diagram, notice that we can select the load combination of interest, the type of diagram, whether it's an axial force or shear. We'll look at moment about the major axis of the members. This is a sticking point, potentially. There are three different options, and this is actually the way that you can clear the diagram. You can set it to erase existing, but when you come in for the first time, it's likely that you'd want to either show the diagrams on all members or on selected members. I'll choose all. Notice that we also have the option to show values and show units, and something that's really handy and relatively new to this version of the program is a plot scale slider. So let's just click apply so that we can see what the effect is, and then see the effect of that plot scale. Now, if you actually did show values, it quickly becomes really difficult to read. So we'll use that as a springboard for taking a look at a tool here on the View tab called Hide All Except Plane. So I might want to take a look at an XY plane positioned right at a Z value of 60, and then notice how that eliminates everything else and brings me right into just that one plane frame, and now I can read the values much more clearly. If I want to restore the whole view of the model, I can say Show All, and then if I want to eliminate the diagrams, I can click Restore Model. We'll come back to Analysis Results and take a look at the Deflection Diagram. I'll leave it set to show the load combination of dead plus wind, but I'll use a magnification factor of 100 and choose some local effects as well. Now we can see a magnified, deflected, or displaced diagram. And it's also interesting to note that you can use animation response or response animation to put some life to it. Sometimes helps to move things a little bit just to pick up what exactly is going on. And then while that moves, I'll also show that we can sometimes superimpose these results as well. So notice that one of these bays is meshed down here. I have shells. I might want to take a look at a contour diagram that shows color displacements of, let's use displacement in the vertical direction, and then say OK. Now if I zoom in a little bit, we can see that the displacement is still animated, as are the deflection colors. And if I had chosen any one of these other types of available contour diagrams, like a stress, it would also be animated as well. And if I come in and use my real-time rotate and do a little bit of moving, we can even see that the colors are superimposed on the deflected shape. So that can be useful for visualizing these effects and really zeroing in on hot spots, stressed areas, and so on.